A very good morning to my dear students. I welcome you all to this fifth semester. So our subject is Control System Analysis and Design. The prerequisite of this subject is Signals and System and Basic Mathematics. So as a control system, first we can see what is the need of studying the subject. In recent years, the concept of automatic control system has achieved a very important position in advancement of modern science. Actually, practically every activity in our day-to-day life is influenced by some sort of control system. For example, if you are considering a fan, so a fan, the speed of the fan can be controlled by using a regulator. This is also one control system. So if you are considering a washing machine, there also we have control system. If you're considering missile, the orientation, those all things are controlled by a control system. So for every activity, there we have some sort of control system. So the concept of control system also plays an important role in the working of space vehicles, satellite, guided missiles, etc. Hence, as an engineer, it is absolutely necessary to get familiar with the analysis and design method of such control system. First, let us see what is meant by system. So, when a number of components or elements are connected in a sequence to perform a specific function, so there we have number of components. It is nothing but a group. We have forming a group. So that group is called a system. So that is collection of objects connected in a design manner to perform a specified task. So this is called system. For example, let us consider our computer. So computer is a system because computer is a collection of CPU, monitor and keyboard. Hard disk like this. So system is nothing but a collection of number of elements or components connected in a sequence to perform a specified task. So now we can see what will be control system. So arrangement of different objects connected in such a manner so as to regulate, direct or command itself is called control system. So we can control the system by regulating, or we have to give some command to control the whole components. That is called control system. Right? So in control system, we have 5 COs. Right? These are the 5 COs, and the textbooks we are following is Control System Engineering by Nagrath and Gopal. Next one is Principles and Design by M. Gopal. Control System Principles and Design by M. Gopal. Next, so for it as an EC graduate, we have some doubt, right? Whether we will have some job opportunity or what is the a future of studying this control system subject, right? So everyone have this doubt. So if we see our alumni, since from 1988 onwards, our alumni place peoples are in good position in the field of control system. In that, few of them have their own companies in control system field. So Mr. Rajkumar and Rajesh Ramanan, I have displayed 2 notable alumni who have their own companies in this domain, in our control system domain. These 2 guys belongs to EC domain, sorry, EC branch. So providing job service to our students in this domain. So our students are getting more opportunity, more job opportunity in the control system domain. These 2 persons are the entrepreneur. Next, by studying this control system subject, we have more job opportunity in public sector. These are the following topics where you will be getting repeated questions in GATE. So this GATE syllabus is splitted into 5 units. That's called a control system subject, right? So mostly all the government exams will be having 15 to 20 percentage of mark weightage in control system. So if you are thoroughly learning this control system subject, you can score 20% of marks in the all the central government exams. So be regular to the classes and have good knowledge in the control system subject. Okay. This is our first unit. The unit 1 is control system modeling. CO1 is explain the various modeling of electrical and electronic system. Let us see what you mean by system. A system is a number of elements or component connected in a sequence to perform a task. That is called system. For example, computer is a system, right? It's a because it's a collection of CPU, monitor, keyboard, hard disk, motherboard, etc. So a system is nothing but number of elements or components connected in a sequence to perform a specific task is called system. So then you have a doubt, what do you mean by control system, right? In a system, when the output quantity is controlled by varying the input quantity, the system is called control system. For example, if you are considering a fan, right, by using this regulator, we can control the speed of the fan. So this is one type of control system. So in this unit, we are going to learn about the terminology of the control system, basic structure, open loop, closed loop system, differential equation, and a transfer function. So you in the signal system itself, you have learned about what do you mean by transfer function, right? You all know about the transfer function, basic things and all. Next, we have to go for a mathematical modeling of electrical system, electronic system. Next, we will go for a block diagram reduction technique, then signal flow graph. So here the important one is transfer function. So we know the transfer function is nothing but ratio of Laplace transform of output to the input, right? This transfer function or a control system, the nature of control system engineering involves consideration of two problems. One is analysis and second one is design. In the analysis, the name itself analysis means this nothing but investigation. So what we will investigate? We will investigate the existing system. So in the analysis, we will investigate existing system, and in the design we will propose a new method what we can improve from the existing method. So in a control system, the first step is get the system either by design or analysis. Next, we will go for a mathematical model. In the mathematical model, what we will do means we will write a mathematical equation. So why we are going for this mathematical equation means to find out the relation between input and output. Right? These are the things we will learn in the transfer function. And next we have there we have a block diagram, right? So there we have a block diagram reduction technique. So why we are going for this block reduction means a control system may consist of number of components. So each system will perform different operations, right? So that is in control engineering. So the functions performed by each component, we commonly use a diagram. So that diagram is represented by block diagram. In control engineering, the function performed by each component is nothing but a system consists of number of components. So this each component we commonly use a diagram. So that diagram can be represented by a block diagram. So let us see what do you mean by block diagram. So block diagram of a system is a pictorial representation of the functions performed by each component and the flow of signals. This block diagram is a pictorial representation of the function. So what are the components performing, that functions can be represented pictorially. and the signal flow. So such a diagram gives the interrelation that exists among the various components. So this is called block diagram. Next, we will go for a signal flow graph. So the signal flow graph is used to represent the control system graphically, and it was developed by S.J. Manson, right? So the signal flow graph and the block diagram approach yield the same information. Both will give the same information, but the advantage in signal flow graph method is that using Mason's gain formula, the overall gain of the system can be computed easily. So this method is simpler method when compared to the block diagram reduction technique. So while going for the block diagram reduction technique, it's some tedious process. To reduce that and to consume less time, we are going for this signal flow graph method, right? Next, Unit 2. The title of the Unit 2 is Time Response Analysis. Here, the CO2 is course outcome is classify the time response analysis. Here we are going to see the topic of standard test signals. We all know about the standard step signals, that is step signal, ramp signal, parabolic, impulse, sinusoid. These are comes under the standard signals. Right? Then first order system, time domain analysis. So why we are going for this time response analysis means input signal is required to predict the response of the, so all the input signal is used to predict the response of the system, but it is difficult to express the input signals mathematically by simple equations. By simple equation we can't express the input signal. So we will use some test signal for this analysis of the control system. So we will go for this time response analysis. For this we will consider different types of signals, and we will analyze how the response of the system, what's the peak time, what's the rise time, how much delay we have, how much overshoot we have, all those things we will learn in this time response analysis. Next, Unit 3. The title of the Unit 3 is Frequency Response Analysis. In this, we are going to investigate the control system using frequency domain plots. Right? So, why we are going for this frequency response analysis means frequency response is a steady state response of a system when the input of the system is sinusoidal. Here, we will consider the test signal as an sinusoidal signal. So practically, testing of the system can be easily carried with available sinusoidal signal generator and precise measurement of equipment. Here, the transfer function of complicated system can be determined experimentally by frequency response test. So complicated, we will easily find out the solution for the complicated system by using this frequency response analysis. Here, when the system is designed by the use of frequency response analysis, the effect of noise disturbance and parameters variation are relatively easy to visualize and incorporate corrective measures. So, by using this frequency response analysis and design, it can be extended to certain nonlinear system too. So here we have some different types of plot. So why we are going for this plot means we have to analyze the frequency response analysis by graphically, because graphically will give an most accurate results. And here we are going to analyze whether the system is stable or not, right? So to analyze this, we will go for different types of plot. One is polar plot, Bode plot. In Bode plot, we will use semilograph, Nyquist plot. So by using this different types of plot, we will analyze whether the given system is stable or not. So next, Unit 4. I am not boring you too much. In this Unit 4, we will go for a stability analysis. Here too, we have to use some different techniques. One is route curve, is root locus technique. So by using these techniques, we will analyze how the system is stable or not in the frequency domain or spatial domain like this. In Unit 5, we will go for state variable analysis. Here we will have some different types of controllability and observability technique to identify the system stability. We will here also we will go for some state equation like mathematical equation to produce some solutions, right? So this is the assessment procedure for our subject. As usual, we have 5 COs now. Each COs have different assessment method. The assessment different assessment method in cognitive and affective domain. So the weightage of each CEOs have the more weightages we have given for this internal assessment test, and here we have this cognitive domain and affective domain, Viva, assignment, class test, MCQ like this, and for every unit we have this course and survey. Whether you have learned how much things you have learned about from this subject like this, we will assess. Like this is the assessment procedure. This is the rubrics for open book test. Please go through this open, what are the rubrics we have given for this open book test and all. Actually, dear students, actually this is a problem oriented subject. You all know. If you can ask with your seniors, you can discuss with your seniors too. It's a problem oriented subject, but it is very easy to score marks unless or otherwise you listen the classes. Okay, so dear students, I request you all to be regular to the classes. Okay, so you have to post your attendance in the Moodle. After watching this video, please take notes, and you have to post the attendance in the Moodle like this. Hope you all will cooperate with me. These are the test books we are following for the already in the first slide itself I have told. These are the test books we are following for our control system. Really very thank you, my dear students. Wish you all the best.